In this video, I'm going to quickly show a little bit more about calculating by hand permutations and combinations, how many of them there are, and I'm going to let you know a little secret about combinations. Here's what we need to calculate. I'm going to calculate how many permutations there are when you have 9 things available and you want to arrange 7 of them. Followed by having 9 things available, you just want to choose 7 of them without arrangement. Because the microphone got muted as I was recording, I'm going to have to do a voiceover. First, I'm going to calculate the smaller one. Both permutations and combinations have no repetition, but combinations also have no arrangement, and so we're going to have a smaller number here. If we think of computing the number of combinations as finding out how many permutations there are and then dividing out the order, thinking of a special application of the multiplication principle, I have 7 tasks, both in the numerator and the denominator. Notice 9 minus 7 plus 1, that's 2 plus 1 is 3. That's the number I end with in the numerator. I'm going to have a whole lot that I can cancel, instead of trying to do all that multiplication in top and bottom and then divide. Do a bunch of cancellation, and then a little more reducing. It's going to leave me with 9 over 4. Sorry, 9 times 4, 36. You should always get a counting number for these answers. So, the first little quote secret. If you cross multiply, then 9p7 should equal 9c7 times 7 factorial. From memory, I'm showing here coming up with 7 factorial. I actually remembered that it was 5040. To go from 4 factorial to 5 factorial, I'm doing 5 times 24. 6 factorial, I'm getting 6 times 120. 7 factorial, I'm doing 7 times 720 to get 5040. So now working out 5040 times 36, if I remember right, my answer was 181,400, but you'll see that worked out in a moment. Okay, yes, 181,440. Doing a quick check on the TI-84, followed by the second quote secret. Again, it's not really a secret. It's certainly something that's helpful if you ever have to calculate these by hand. And while 9c7 is 36 is being checked here, something I may have hinted at in a previous video. With 9 things available, and you want to choose 7 of them without repetition and without arrangement, that would be the same as leaving out 2 of them without repetition and without arrangement. So my claim here is that 9c7 equals 9c2. I'm about to show that worked out on paper that I get 36 there. Here we go. 9C2. Much less to do in the numerator and denominator, 2 tasks. First, arrange without repetition in the numerator, and then in the denominator, divide out the order. 2 special applications of the multiplication principle, 2 blanks for each. Much less reducing to worry about. 9 times 4, 36 again.